It all began with a whisper from the cold, dark emptiness of space. In late 2025, astronomers tracked a comet called 3I Atlas. At first, just another icy visitor. But this comet was different. Its tail showed complex, organized patterns, as if carrying a message. Rumors spread. Was this natural, or something more? Meanwhile, China's Advanced Quantum Telescope detected mysterious fleeting signals from deep space, signals that defied conventional physics. The timing was uncanny. A comet with a coded tail, and a telescope picking up inexplicable signals. Could these events be connected? Was the comet transmitting, or was something using it as a cover? The scientific world buzzed with questions, and the mystery deepened. For the first time in years, the universe felt like it was speaking directly to us, if only we could understand. The stage was set for a new era of cosmic discovery. In November 2025, leaked data from the 3I Atlas mission sent shockwaves through the scientific community. The findings confirmed that the comet's tail contained intricate, unnatural structures, unlike anything seen before in natural cosmic phenomena. These weren't random swirls, or chaotic dust trails. They looked engineered, as if something, or someone, was deliberately arranging the dust and gas with advanced technology, far beyond our own. The patterns seemed almost intentional, like a message, in an unknown language, carefully woven into the fabric of the comet's tail for us to find. The leak also revealed the use of cutting-edge quantum sensors, capable of detecting subtle, hidden properties in space that traditional instruments would miss, opening a new window into the cosmos. China's quantum telescope, which had picked up strange, unexplained signals months earlier, suddenly became the focus of global attention. These signals weren't radio waves or electromagnetic pulses. They were faint, organized quantum disturbances, almost like ripples in the very fabric of space itself, hinting at a new form of communication. The telescope was built to detect these whispers from the universe, and what it found suggested intelligence, patterns too precise to be random. For decades, we searched for alien life by listening for radio waves, hoping for a signal that would rise above the cosmic noise. But what if advanced civilizations communicate in ways we're only now beginning to detect? Silent, quantum signals instead of loud broadcasts. Perhaps their messages have always been there, hidden in plain sight. The universe was talking, but we were just learning how to listen. Tuning in to a frequency we never knew existed. The comet and the signals together hinted at a new kind of cosmic conversation, one that could change our understanding of life in the universe. We were on the verge of understanding a language written in the quietest code imaginable, a message from the stars, waiting for us to finally break its silence. As the world puzzled over these mysteries, experts everywhere searched for answers, combing through data and theories late into the night. Then, China announced a breakthrough that stunned the global scientific community, something they called radiotelepathy. This wasn't mind-reading or science fiction, it was real communication but without any detectable signals in the air. Military vehicles could now send data, maps, orders, even live video feeds, without emitting a single watt of energy of their own. The secret behind this leap? Smart surfaces made of programmable metamaterials, engineered at the nanoscale to manipulate waves. When a friendly satellite's radar beam swept over, the vehicle's surface would reflect it back, encoding a hidden message in the reflection, like a mirror sending a secret code. The vehicle itself stayed completely silent, invisible to enemy sensors and undetectable by conventional means. No radio chatter, no electronic pulse, just a ghost on the battlefield, leaving adversaries confused and searching for answers. This passive one-way link borrowed the satellite's energy for only a split second, leaving no trace and no evidence of communication. The idea was simple, but revolutionary. Talk by changing the way you reflect light or radar, instead of sending out your own signal. The implications went far beyond the military, sparking excitement in scientific, commercial, and even humanitarian circles. This technology could transform how we communicate in space, quietly, efficiently, and undetectably, even across vast distances. Suddenly, the way we talk to our machines, and maybe even to the cosmos itself, was about to change forever. The age of silent signals had begun, opening a new chapter in the story of human connection. So, how does radio telepathy actually work? What's the science behind these silent signals that seem to travel invisibly through the air? Imagine the difference between a flashlight and a mirror. One creates its own light, the other simply reflects what's already there. This simple analogy helps us understand the core idea. Traditional radios are like flashlights, active, obvious, and easy to spot because they send out their own signals into the world. But China's new system is different. It turns vehicles into smart mirrors, reflecting satellite radar beams and encoding secret messages within those reflections. The system has two main parts: a satellite equipped with synthetic aperture radar, and a vehicle covered in special metamaterial tiles that can manipulate electromagnetic waves. The satellite's radar beam acts as the illuminator, bathing the ground in invisible energy, just like sunlight shining down. The smart surface on the vehicle instantly changes its properties, encoding streams of data into the reflected radar beam with incredible precision and speed. It's like flashing Morse code with a mirror, but at a scale and complexity that's almost impossible for the human eye to detect. Millions of bits per second. The vehicle itself generates no signal of its own, just a silent, data-rich reflection that blends into the background. Enemy sensors searching for energy spikes or suspicious transmissions find nothing out of the ordinary. The message is hidden within the satellite's normal radar sweep, undetectable amid the noise and clutter of everyday signals. This stealthy method is a game-changer for secure communication, making it nearly impossible for adversaries to intercept or even notice the exchange. And its potential for space exploration and interplanetary communication is just beginning to be realized, opening new frontiers for silent, secure messaging. In essence, we're learning to talk in whispers, not shouts, communicating in ways that are almost invisible to the outside world. This silent communication could revolutionize space exploration. Small probes to distant planets struggle with power. Big transmitters and antennas are heavy and expensive. With radio telepathy, a probe covered in smart surfaces could reflect signals from a powerful radar satellite, using almost no energy. Fleets of tiny, cheap probes could explore the solar system, dedicating power to science instead of communication. Navigation would improve, too. Radar satellites could track probes passively, creating a solar system-wide GPS. Less radio noise means better conditions for astronomers searching for faint cosmic signals. By communicating quietly, we'd become better listeners, both for science and for the search for life. The same technology that hides tanks could open the universe to us. The future of exploration might depend on how softly we can speak, and how well we can listen. The age of noisy transmissions was ending. China's advances in quantum and passive communication sparked a global race. India emerged as a key player, building its own secure quantum network. In late 2024, India chose the high-altitude Hanley Observatory in the Himalayas for its quantum ground station. The thin, stable air there is perfect for sending delicate quantum signals to satellites. Even so, adaptive optics are needed to correct for atmospheric distortion. India's careful planning is part of a worldwide push for quantum key distribution, unbreakable encryption that alerts users to any eavesdropping. By securing Hanley, India positioned itself as a serious contender in the quantum race. The stakes: national security, scientific leadership, and a place in the next era of communication. The world was preparing for a future where secrets and discoveries travel at the speed of quantum light. The race for quantum supremacy is global and intense. China's Michus satellite proved quantum signals could travel between space and Earth, setting the pace. The US responded, making quantum technology a national priority for security and economic power. Europe and Canada launched their own quantum satellite programs, aiming for a hack-proof quantum internet. The competition isn't just military, it's about building the backbone of tomorrow's global economy. Each breakthrough, from satellites to ground stations, pushes the boundaries of what's possible. While nations compete, the science is universal. The tools for secure communication could also help us detect faint signals from distant worlds. In learning to talk securely, we might finally learn how to listen to the universe. These breakthroughs in quantum and passive communication are changing everything. We're learning to communicate with whispers, not shouts, a shift that could unlock the universe's biggest mysteries. For decades we searched for alien life using radio waves, but what if advanced civilizations use silent, quantum signals or passive reflections? The strange signals and comet patterns might be our first glimpse of this new language. We're also getting smarter about searching for life, looking for new biosignatures, like methyl halides, that are easier to detect than oxygen. The James Webb Space Telescope could spot these signs on distant worlds in hours. The search for new ways to communicate, and the search for life, are deeply connected. Our new tools might reveal both secrets and neighbors in the cosmos. The future is listening. And for the first time, we might finally hear what the universe has to say.